And welcome back. So in this video we're going to continue looking at covalent bonding, focusing more on the actual bonds themselves. So hopefully by the end of this video you'll be aware that there's actually two different types of bond that make up covalent bonds, and you should be able to represent them by drawing orbital overlap. So in the previous video we went through dot and cross diagrams for covalent bonding, and we started to explain them using orbital overlap. So I'm just going to remind you by drawing one more example. Now, the reason I want to do this example is that it's a slightly more complicated example than the ones we went through in the previous video. So the example I'd like to use is methane. Okay, so in methane there's one carbon bonded to 4 different hydrogen atoms. Now the reason I want to go through this example should be made clear once I've drawn the orbital diagrams. So carbon has the electronic structure of 1s2, 2s2, 2p2. So if I draw the orbital diagrams of this, you should hopefully be spotting a problem with the method we used in the previous video. In that video, we formed covalent bonds by overlapping unpaired orbitals. But in this example, there are only 2 unpaired orbitals, whereas we know the carbon bonds to 4 hydrogens. So what actually happens? Well, you get what's called expansion. Making 4 bonds is more beneficial to the carbon than making 2. And the energy saved by making those bonds overall allows one of these electrons to be promoted to a different subshell. So one of the 2s electrons is actually promoted to the 2p. So we now have 4 unpaired orbitals. So I've drawn in the 4 orbitals for 4 different hydrogen atoms. Obviously they only have a 1s orbital each. So these orbitals can now overlap with the unpaired orbitals from the carbon atom. So we now have our 4 covalent bonds. So the reason I wanted to go through this example, one, it's a little bit different to the ones we looked at in the last video. And I also wanted to remind you that the covalent bonds were formed through overlap of orbitals. Now I also just want to draw your attention to the fact that we have overlap between different types of orbital. So here, this covalent bond is formed from the overlap between a 2s and a 1s. Whereas these 3 are the overlap between p subshells and s subshells. Hold that in your mind for the rest of the video. So I mentioned that there were different types of bond which make up a covalent bond. Now that is involved with the types of orbital that are involved in the overlap in the covalent bond. So hopefully you'll recognize the shape of an s orbital. So when we get 2 s orbitals overlapping, we can form a covalent bond. We can also have an s orbital overlapping with a p orbital, or we can have 2 p orbitals overlapping. Now each of these covalent bonds involves the orbitals overlapping in line. So you can see the overlap in all cases is in line with the centers of the 2 atoms. So all of these are examples of what are called sigma bonds, which can either be written with words or with the sigma symbol. Now a sigma bond is what you get in a single covalent bond. It doesn't matter which of these 3 you have, they will all count as a normal single covalent bond. But that's not the only type of bonds you can get. You can also get overlap that looks like this. So obviously there are 3 p orbitals per atom. Now there will be p orbitals which are in line with each other, but there are also p orbitals that are perpendicular to the line between the centers of the atoms. Remember, you have a p orbital on both the x, y, and z axes. Now this type of bond is what we call a pi bond, which again can be written as words or using the pi symbol, which I'm sure you've come across in maths. Now when we have a double bond, this is the second bond involved. So a double covalent bond is made up of one sigma bond and one pi bond. Now if you look at data for the strength of bonds, you will notice that a double bond, let's say a carbon-carbon double bond, is not twice as strong as a carbon-carbon single bond. And the reason for that is that this overlap is not as strong as the overlap you get in a sigma bond. So the pi bond is weaker than the sigma bond. Now we can also get triple bonds. We looked at the example of N2 in the previous video. Now a triple bond will contain one sigma bond and two pi bonds. So you need to be aware for single, double and triple covalent bonds, what types of bond actually make them up. You need to be able to draw the diagrams I have and the ones we looked at previously. And you have to be aware that these pi bonds are weaker than the sigma bonds and how that affects the overall strength of the bond. So hopefully you are now aware of the two types of bond that make up covalent bonds, and you should be able to sketch the diagram showing the overlap for these two different types, the sigma and the pi bond. Okay, if you have any questions, make sure you write them down, and I'll see you in class.